Hello, everyone. So, yesterday we learned how to use the theorems in proofs to prove certain angles are congruent. And our theorems were if lines are parallel, alternate interior angles are congruent. If lines are parallel, alternate exterior angles are congruent. If lines are parallel, corresponding angles are congruent. If same side interior angles are supplementary, or if the lines are parallel, same side interior angles are supplementary, and if lines are parallel, same side exterior angles are supplementary. So today we're going to learn an idea that's called the converse. The converse of our theorem is backwards. So the first theorem we talked about, or the first theorem we're going to talk about today, is we had learned yesterday if the lines are parallel, corresponding angles are congruent. Well, if I read that backwards, it says if corresponding angles are congruent, then the lines are parallel. Now, it's important to note that not all theorems are true backwards, but the 5 we learned yesterday are indeed true. So, if alternate interior angles are congruent, then the lines are parallel. If alternate exterior angles are congruent, then the lines are parallel. If consecutive interior angles are supplementary, then the lines are parallel. If exterior angles on the same side of the transversal are supplementary, then the lines are parallel. So I want you to try numbers 1 through 5 right now, which 1 through 4 is you're going to figure out which lines we can say are parallel. And then number 5, you're going to show work to show me that M and find X so that M is parallel to N. So pause, try these 5, and then come back. All right. So 1 and 3 being congruent implies J and K are parallel because corresponding angles are congruent implies parallel lines. 2 and 5 being congruent also implies J and K are parallel because alternate interior angles congruent implies parallel lines. Angles 3 and 10 imply L and M are parallel because alternate exterior angles congruent implies parallel lines. And last but not least, number 4, L and M, because same side interior angles are supplementary, implies the lines are parallel. Number 5, in order for M and N to be parallel, those two angles have to be congruent. Therefore, X equals 20. So now how can we use this in a proof? So let's take a look at this. So we know, based on the given, that angle 2 is congruent to angle 1. And we know that angle 1 is congruent to angle 3. And I want to prove that ST is parallel to UV. So if I look at that first, before I start to do any of the work, I'm looking at ST and UV. Well, there are two possible transversals. There's SU and TV. But when I look at SU, I only have one angle that I know anything about on SU. However, if I look at TV, I have two angles, 3 and 2. So I really want to focus on TV being my transversal. So if TV is my transversal, in order to get those lines parallel, I want to get that 3 is congruent to 2. Well, let's see what we can do. So I'm going to start off with my statements and my reasons. And right away, when I look at what I'm given, which is 2 is congruent to 1, and 1 is congruent to 3, I know that I can say 2 is congruent to 3 because of transitive, or you could call it substitution. Because if 2 and 3 are both congruent to 1, they have to be congruent together. So that's transitive. So that means that 2 is congruent to 3, which those are, if TV is my transversal, alternate interior angles. Therefore, ST has to be parallel to UV. And my reason is alternate interior angles congruent implies parallel lines. Done. Number 7, we got a little more complicated here. So I want you to pause and try it for 5 to 6 minutes. and then come back and I'll go over it. All right, so hopefully you tried this a little bit on your own. For me to start this, what I'm going to do is I'm going to start off by highlighting the lines I know are parallel. So I know JM, and that was a horrible job highlighting. Let's try that again. JM is parallel to KN. Oh, well, look at that. That means JL is a transversal. Okay. So then I know that angle 1 is congruent to 2. And I know angle 3 is congruent to 4. And what I want to get is that KM, so what I'm after is KM being parallel to LN. And I really wanted that in a different color. Okay. KM being parallel to LN. So let's see what I can do. So statements, reasons. So that first thing tells me that those two lines are parallel, and I notice that they have the transversal JL. So knowing that JM is parallel to KN, and I have that transversal, that tells me that 1 is congruent to 3 because those are corresponding angles. So I'm going to go ahead and do that. So parallel implies corresponding angles congruent. So that's just from my first given. My second given is 1 is congruent to 2. Okay, and 3 is congruent to 4. Okay. Oh, but wait a minute. I said 1 is congruent to 3. And then if I look at that, to get the green lines parallel, really what I want to be able to say is that 2 is congruent to 4 because those are corresponding angles. So if I look at what I have here, I know 1 is congruent to 3 and 1 is congruent to 2, 3 is congruent to 4, and 1 is congruent to 3. So if I start with the 1 is congruent to 2 and 1 is congruent to 3, that means 2 is congruent to 3 because of transitive or substitution. And then if I look at 2 is congruent to 3 and 3 is congruent to 4, I can say 2 is congruent to 4, which is again is transitive. And then those are the angles I want. So that means I can say KM is parallel to LN because corresponding angles congruent implies parallel lines. And I'm done. So that is the end of today's videos. Again, if you have any questions, please bring them to class.